This is the algebra skills review that goes along with Chapter 4. The topic is solving equations. So our first example goes through all the 5 steps to solve an equation. So the first thing I notice is that I have parentheses here. If I have parentheses, I know I have to distribute. So when I distribute, negative 4 multiplies 2x, I get negative 8x. Negative 4 multiplies negative 7, I get a positive 28. Now I see that I have a negative 8x and a 2x over there. So I'm going to combine those together. So second step, combine like terms. The 4x plus 8 stays, the equal sign stays. Negative 8x and a 2x become a negative 6x, and the plus 28 stays. The next thing I notice is that I have letters on both sides. So what I'm going to do is I'm going to get this negative 6x out of here by adding 6x to that side. That means I have to add 6x onto the other side also. So if I add 6x here, I'm going to have to add 6x over here. So that gives me a 10x, plus 8 comes down, the equal sign comes down, negative 6x plus 6x goes away, and I'm left with 28. Now my job is to get x alone, and right now I have a problem because my x has a 10 in front of it, and it also has a plus 8 after it. The steps say, fourth step, get rid of any numbers on the side with that letter, and you get rid of them by adding or subtracting. So therefore, I'm going to subtract 8 from this side and subtract 8 from that side. So when I subtract 8 from both sides, 10x comes down, 8 minus 8 is gone, the equal sign comes down, and 28 minus 8 is 20. The fifth step in solving an equation is to get the letter alone. If it has any multiplying and dividing with it, you need to get rid of that. So if I have a 10x that's multiplied by 10, so to get rid of it, I divide by 10. And when I divide by 10, I have my x alone, my equal sign, and 20 divided by 10 is 2. So this should bring back fond memories of solving algebra equations. This one I bring up because it says when an equation contains fractions or rational expressions, it is sometimes easiest to clear them by multiplying both sides of the equation by a common denominator. So it's really hard to work with fractions. Students have a difficult time with it. So instead of taking this equation that has all fractions in it, what if I multiply by the common denominator to get rid of those fractions? So the denominators now are 2, 5, and 4. So the least common denominator I can think of that all those numbers divide into is 20. So I'm going to take this original equation that I have, and now I'm going to multiply everything by 20. I'm going to multiply this side by 20, and I'll multiply the right-hand side by 20. So I am going to go from here to here. So I'm going to take 2 goes into there once, 2 goes in there 10 times, so I'm going to have 10x. And then 5 and the 20 are going to cancel. So I'm going to be left with a 4 outside here, and 4 times 3 is going to be 12x down here. And if I multiply 20 times a negative 1/4, I'm going to have a negative. And 4 will go into 4 once on the bottom and into 25 times, and 5 times 1 will be a 5. So I kind of ignored this step. Okay, then I have letters on both sides, so I'm going to get rid of this 12x by subtracting 12x from both sides. So I get a negative 2x equals a negative 5, and then divide by a negative 2 to get x alone. There are 2 more slides with 2 weird situations that happen. Here's the first weird situation. I distribute, and I get 4x plus 8 equals 2 times 2x will be 4x. 2 times 4 is going to be a positive 8. Okay, if I have letters on both sides, I'm going to subtract 4x from the side to get the letter over to the other side, and what happens is 4x minus 4x goes away, I'm left with 8. Here's the equal sign, 4x minus 4x goes away, I'm left with an 8. I've lost my letter. So since I've lost my x's, and I'm left with a true statement, 8 does equal 8, I know that all real numbers will work in this equation. So if I put a 3 in here and a 3 in here, I will get the same exact thing on both sides. If I put a 4 in for x, or a 4 in for this x here, I'm going to get the same thing on both sides. They're going to be equal. So any number that I can think of that is a real number is going to work in this equation. So how did I know this was kind of strange? Because in solving it, I lost my letters. And when I lost my letters, I looked at the statement I did have, and it was true. Since it is true, it means that there were many solutions to this, not just one. Okay, here's the other weird situation. Again, I have parentheses, so I'm going to distribute. And when I distribute, I get 4x plus 8 equals 2 times 2x is going to be 4x. 2 times 2 is going to be the 4. I have letters on both sides. So I'm going to try to get rid of this letter by subtracting 4x. And when I do that, the 4x minus 4x goes away, I'm left with 8. An equal sign, 4x minus 4x goes away, I'm left with a 4. So again, I lost my x's, but this time I have a false statement. 8 equals 4, that is false. When you have a false statement, that means that there are no solutions to the equation. And you can kind of see that back in this step. Here I have a 4x and a 4x, and here I'm adding an 8, and here I'm adding a 4. So if these are balanced by putting any number that I wanted, they're not going to be balanced when I add 8 to one side and 4 to the other side. So there's no number I can think of that's going to make this equation be true. So there is a fast review of solving equations with the two weird situations that sometimes occur.